So my project, I set out to implement trading contracts based on the idea of frequent batch auctions. And this is in contrast to like order book based trading, where on the order book, if in case of order book based trading, people place orders into a live order book, where you place an order, it immediately appears on the book, and if it matches some of the existing orders, then it's immediately filled. And with batch auctions, people submit orders, and they are kind of gathered, like batched together and periodically executed at price, which is sort of like an average or like the best price for like a single price for all the orders that cross with the price. So there is like a settling price that's calculated based on an algorithm which fills as many orders as possible at a single price. There's various papers out there which argue that it's this kind of trading. This is one of the papers. I have a link in my repo to that. There's a few links there. I'm gonna post in the chat if anyone wants to. Oh, so this is one of the papers about this, and the claim is that it kind of makes it more beneficial to normal market participants, and prevents market makers from extracting more value, and supposedly market participants get a better price at the expense of professional market makers earning less in their from their activity. But these claims have been kind of also not fully refuted, but like they have been criticized that they're not accurate, and it's currently not a dominant strategy on the centralized exchanges. And so yeah, so I tried to implement this, and maybe like I didn't get far, to be honest. So I'm more gonna talk about like my learning journey and show what I've got so far. So initially I started with something simple, just so that I can learn the basics and figure out the flow with like unit testing and working with this feedback loop where I edit the code, run the tests automatically, and see what I get. So I implemented something which I call two-party price negotiation. So it's only two parties, one submitting a sell order saying I have this two assets and I have this one asset, and I'm going to I want to trade certain amount of this asset at a certain price, and the amount of the amount of the asset is made public, but the price, which is like in here expressed as the amount of the other asset that the person wants in return, that's secret, and that's submitted to the contract as a commitment. So then we have the phases in this contract is like a one-shot contract. It's deployed and initialized with commitment from the party A. Then some party B comes along and can commit to say, okay, I'm going to buy that amount of your the asset you want to sell, and I'm going to commit to certain price, which is also secret at this point. I mean, to be honest, at this point, it could probably be made public straight away, but I just kept this commit and reveal for both parties. So it has to, the contract enforces that at each step, there's only one possible state transition. So from after commitment A, you need to commit B, and then A has to reveal and B has to reveal. You could theoretically have A and B reveal in any order, but this was just for simplicity. And then in the end, you submit the settle transaction, which then compares the two prices, and if they're matched, then it says, okay, it's settled. Otherwise, it sets the phase to the phase to cancel. So that was like the first thing I did, and yeah, and once I had like more confidence, I decided to expand. So the next steps would be to allow multiple parties submit orders. And obviously for that, we couldn't store everything. This is here, everything is stored in on-chain storage, but then with multiple parties submitting many orders, we'll need to use some Merkle tree. So the next step, I decided to use a Merkle map. And in this, well, that's not that one. Two-party batch action. Okay, so in this one, we only have one piece of state, or two pieces of state. Initially, it was just one. So we have the root of the Merkle map, which is under the hood implemented with Merkle tree, yeah. And then and there is the order count. Currently, actually, order count is not, I believe, not used for anything. But yeah, so with the Merkle map, we can now commit to orders, and now they are fully private, so you don't reveal anything. I mean, the contract still is about just two assets, so the assets are fixed, but you can commit to an order which is the amount of asset A and price, and the amount can be negative or positive. So if you want to sell, it's negative. If you want to buy, is positive. And yeah, and then the price. So this was done by having the commit order message for that. So you submit your private key. Okay, so the keys in Merkle map are private, public keys of the people that submit. So that's a bit of a limitation because you can only have one order per party. But again, this was my first attempt at it. So yeah, so we have a private key, we have an order, the order and commitment witness, where you need to know the current. So you need to know the current state to change the state to a new root. So here we assume that the commitment witness for your key, which is your public key calculated from the private key, has to be 0, means like it's not present, and then you can commit to your order, where we get the order commitment, which is just hash of that order, and we update the root. And then at the end, the idea is that each time somebody updates the root, when they commit the order is emitted, the commitment and the key is emitted on as an event. So external parties can monitor for those events and build up the state as it's updated. I don't know how reliable the event mechanism is for that. If I'm a third party listening to those, can I be certain that I get all of them? But the condition for you to take part in this is that you need to know the full state. You need to know the commitments. Yeah, all the commitments that have been committed so far for you to submit your own. And that's also like a limitation where you, so let me have a look at the message.
Oh, yes, it's me, Adrian. Just you have a minute left. Sorry about that.
Oh, okay, sorry. Okay, yeah. So yeah, and then there's the reveal phase where you submit your actual order, and it's checked against your commitment, and then order revealed is emitted. And at the end, so I got to a stage where like, okay, now we have all the orders, and then we want to settle them. And I started working on, like, I started thinking about how do I calculate this, the final clearing price. And it was the first time I dealt with this kind of trading mechanism. So I did some research and discovered a paper which actually implements the same system on top of Ethereum, also with some zero knowledge proofs for the for keeping the commitment private. And I copied some implementation for their calculation of clearing price, which is in JavaScript. Adapted it a little bit, and then started thinking, okay, how do I now implement this in Snarky? So I started doing it. I didn't get far because I kind of, yeah, I did get some errors sometimes when I was trying to do things like I get an array of orders. So somebody that to settle would have to most likely submit all the state, which is like an array of all the orders. And then we need to, I got to the stage where I can verify that those orders are the right orders, like the orders as saved, they match the root that is on the state. And I can assert certain things about the orders. I can assert like sort them by price, which is part of the algorithm of calculating the settlement price. But the calculating of the settlement price is actually quite and calculating which orders should be settled by which amount, because some orders may be partially settled, for example, is quite involved. So yeah, so I kind of hit a little bit of roadblocks with yeah, can I do everything the same as if I'm just doing pure JavaScript or not? If, for example, I want to sort the orders, can I sort them, and is that verifiable, or should I submit the orders already sorted and just verify that they're sorted? Yeah, I did have some funny errors which were difficult to diagnose because they're pointing at some place inside the Snarky JS like code, which yeah, didn't tell me much about where the error is. So yeah, so I did hit some roadblocks there in figuring out if I'm taking the right direction when doing those complicated calculations and things like that. So yeah, everything I've got so far is on the GitHub repo that I posted with some more links. And yeah, I hope to kind of make some more progress gradually in the future on this and arrive at some final implementation. And then on top of that, I'll have to then add the actual like things that to make it actually real, where you have some custom tokens on Mina, and then you actually lock people's balances before they commit, and then unlock them when they settle and send people the tokens that they got from their trades. So there's quite a lot to be done, but it turned out to be much much bigger task than I anticipated. So yeah.